All right. Just someone online could let me know that they do see the screen that I'm sharing. Okay, great. So today we are going to start out with Module 8. Actually, before we jump in, let me just give you everyone kind of a heads up what's going on. So today is our last class. And I'm sure you all are going, but next week's last week, right? In my opinion, it's too hectic to have class on a Wednesday night and then expect for you to have everything done and turned in the next day, right? So because of that, I run the class a little bit ahead of schedule, just so that way this week, which is 2 modules, I give you the extended time so you're not due until next Wednesday at midnight. But we're going to cover everything tonight, and then we'll call it, this is the last class, right? So I just found it was too hectic. And then I would try things like making it to where things weren't due until Thursday midnight. And then I had to get up at 5 in the morning to grade final papers and get them in, because I have to have my grades in by noon on Friday. It was too hectic for me. It was too hectic for students. Because there's always that last person or that one person that, man, they just need that little bit more time, or they need a little bit of help in getting together, and they always wait till the last minute. So by making today the last class, as well as everything due by midnight next Wednesday, it gives you a little bit extra time to do 2 modules. Also, Module 8 is not really complicated. It's essentially just understanding some information, and then from there, going ahead and applying it in a quiz. What I will tell you about that quiz is it is manually graded by me, and that's because you have to list out your work. You can't just put the answer, because we all can appreciate that you can go in, and Google has translators. If you've got a Windows PC, I'm sure Mac does it as well. You can go in the calculator, you can plug it into the calculator and then switch it over to one of the other bases, and it'll give you the answer. So we really want to see how you got to the answer. So please understand, if you just give me the answer, you're not going to get full credit for the problem, and you'll probably only get about 1/3 credit per problem. So please make sure you actually show me the steps. And we'll kind of see that as we go through and talk about what the number system looks like anyway. So let's go ahead and jump in with that. If there's any grades or anyone has any confusion, I will be looking to probably grade tomorrow, pretty much up to current. So everything but this Module 8 and Module 9 will be done. And please take a moment to look over your grades, make sure I haven't missed anything. I'm human, I make mistakes, not often, but I'm allowed 1 or 2 per year, as my fiance would say, 1 or 2 a day. But that's okay. So just check your grades. Really, it's a lot easier if you look at your grades and go, oh, hey, look, this is wrong, and I go in and I fix it, rather than after the fact you get a B when you should have gotten an A, because then I have to put in a change request, and it just involves a lot of people, and they're really slow on those change requests. I've seen it take as long as 2 months to get your grade changed. So especially if you are sitting on the edge of your GPA of probation versus not, you don't want to take that chance. So make sure you just check your grades before midnight of Wednesday, to make sure everything is good and up to speed for the current grades. And then I would even go in on Thursday. I will grade everything on Thursday. Just check your grades again. Make sure those last grades are correct. All right. So jumping into the module, I actually have a t-shirt that says this. I love it. There is only 10 types of people, those that understand binary and those that don't. And the reason why this is a great t-shirt, and by the way, I don't wear this shirt out anymore whatsoever, because everyone just comes and stops me and goes, I don't understand your shirt, because they're thinking base 10, or this is base 2. Yes. No, the number 10 in binary is actually 2.
Oh, I see. Right. So, right, ones represents the people who do understand it, and 0 represents the people that doesn't. Or it's the other way around that. No, they represent.
Well, 10 in binary just means 2, right? Oh. So this is actually saying there is 2 types of people. It's just the 10 is in binary, not in decily. All right, so let's jump into that and kind of understand that. So, all through our lives, we have been on a base 10 system. It makes sense. It's really simple. It's well-rounded. In fact, there was a push back when I was a kid to move us from our current U.S. imperial system and measurements to a more metric system, which is also base 10. And it made a whole lot of sense. We just never really adopted it well. And at some point, we just kind of gave up. But we've always been doing 10s. Now, think about when we talk about in base 10, we say the ones place, the tens place, the hundredths place, and the thousands place, right? And we keep going. And the reason why we use those numbers is that's exactly how it translates. So the 7 is in the ones place, and that's why we take 7 and we times it by 1. 4 is in the tens place, and we take 4 times 10. We keep doing this, and then we add those numbers up, and that's how we get 6,347. And that's how it's represented in a base 10 system. So let's look at another example of that. And now what we're going to do is we're going to get a little bit more sophisticated. We're going to start using exponents. And all this statement is up here is exactly this statement down here, except that we're saying the number times the base raised to the position. What is 10? And remember, whenever we take 10 and raise it to the 0 power, what are we saying? What is that number? It is 1. It's always 1. So kind of keep that in mind. So 7 times 10 to the 0 power means 7 times 1. 10 to the first power means 10. It's multiplied only by itself. So 4 times 10 to the first power is 4 times 10. And then 3 times 10 to the second power, which we know is 100, and as you can see, as you catch on, all we've done is taken this simple math of the number itself in our number times the base that we're in, raised to the position of where it is in the number. So 7 is in the position of 1, 7 is in the position of 0, 4 is in position 1, 3 is in position 2, and 6 is in position 3. So what does that mean? So here's the pattern that we kind of just stumbled across. This first way is very similar to what you'd see oftentimes in a lot of programming languages. Not exactly Python. In fact, Python uses the double star to mean raised to the power of, right? In most other languages, and also when you're typing things out in like a Google calculator or something like that, the caret sign actually means raised to the power of. So what we have is we have the number itself times whatever base number we're in. So whether we're in base 10, base 2, or base 16, which is hexadecimal, this is always going to be the same number. It's always whatever our base is will always be that beam. You can see that up here. It's always 10, 10, 10, 10. It's always going to be the same number. And then it's raised to the position where n is located in the number. So as we said, 7 is located in the 0 position, 4 in the 1, 3 in the 2, and 6 is now in the third position. And we keep doing that for how many ever positions we have. And then once we've done all that math, we add them all together, and that's how we get our number. I kind of did a little bit more fancy here to make it a little bit easier to read. So again, it's the same concept. The number that we're dealing with times the base, and the base number is always going to be the same, raised to the position that the number is located. All right, so let's talk about base 2. It's the same thing. The biggest difference is we're going to put 2 in the base or that B location, right? So it's always 2, 2, 2, 2, 2. And the difference here is that we're only going to see zeros and ones, because 1 is the highest number you can have in a base 2 system. So same thing with this. We've got the 0 position, the 1 position, the 2 position, the 3 position, and the 4 position. So here we have 1 times 2 to the 0 position, which is 1. 1 times 2 to the first, which is 2. 0 times 2 to the second, which is 4. 2 to the third is 8. And 2 to the 14th is 16, which comes down to the 16 plus 8 plus 0 plus 2 plus 1. 27 in base 10. That's taking this number and converting it to base 10 would be 27. Any questions so far? All right. Sorry? Okay. So here we are, just a bigger number. 10111101. Again, if you start on this side, you got position 0, then 1, 2, 3, 4, 5, 6, and 7. And as you can see in the red, they've highlighted the numbers. They've done the math. And when this is all added up, it's 189 in a base 10 number. So this number, because what we're doing here is as we are writing this out, we're already starting to convert it to base 10. Because 128 does not exist in base 2. So the fact that we have a 128, this is already mostly converted to base 10. I mean, it is converted to base 10, it's just the math hasn't been done yet. So that's why we put 189 in base 10. Sometimes when you know that you are dealing with base conversions, you're converting from base 2 to base 10, oftentimes they will put the base as a subset number. So what you would see here is oftentimes, and again, they only do this when everyone's aware that you're talking about the base. So they'll go and they'll say 10. And you don't want to do this if the entire audience is not aware that you're talking about base conversion. So for example, they'll oftentimes go so that way you know it's in base 2. All right, let's get a little bit more fun. Let's talk about hexadecimal. Hexadecimal is just a fancy word for base 16. Hexadecimal stands for 16. So if you think about it, there is 16 numbers, so 0 through 15 in a hexadecimal number. Now there's a slight problem is hexadecimal being base 16, we don't actually have a number, a 1 position number that stands for 11. And so because of that, we actually substitute letters. So when we hit 10, instead of saying 10, because it takes 2 digits now, we're going to say A. and 11 is B, and so forth and so on, C, D, E, and F. So with that being said, when we look at a number that's in hexadecimal, one good giveaway is you start seeing letters in it. But don't always count on that because, again, the number 999 could be in base 16 format in hexadecimal and would mean significantly different than 999 in decimal. So B7D, we use the same formula, and that is our B is always going to be 16 now. We're going to put the number out front. So B is 11, then we got 7, and then D, which is 13, and then raise it to the power. So D is in the 0 position, 7 is in the first position, and B is in the second position. So that being said, we have 11 times 256 plus 112 plus 13. So this number is 2,941 in base 10. So we just talked about this. 999 in deci. Deci to deci, right? Which means it's physically 999. 999 hexi to deci equals, let's do the math. So we know that our base is 16. So we're going to say n times 16 plus n times, sorry. So we know that the first digit is 9. The next digit is also 9. And then the third digit is 9. But this is in position 0. This is in position 1. Oh, excuse me, messed that up. And this is in the second position. By the way, when you're doing this on the test, the best way to do this is I would recommend breaking it up into separate lines like this. Because then you can say, well, let's just, $16 squared times 9. It's 2,304. Nine times 16, 144. And we know that 0 position always means 1, so 9 times 1 is 9. So 999 in hexi to deci actually equals 2,457, right? Let me get that number. Yep. So big difference between 999 in deci and 999 in hexi. Do y'all follow how I did that? And I broke it down with the particular positions. All right. So let's take another example of hexadecimal to deci, which is firstly f equals 15. So we know that we have base 16. So each position is going to get a 16. And then we're going to times it by each position by f, which is 15. So here's 15 times and 15 times. And then let's put the position in. We know the first f is going to be position 0. And then that's position 1. So there we have 15 times 6 to the first power is 244 plus 15 times 6 to the 0 power, which is 15 times 1 is 15. So we have 255 in base 10. So note that 1111 colon 1111, which is nothing. This colon is just there to help you visually see the number a little bit easier when it's in decimal, right? So whenever we have a number in decimal, you'll see, or oftentimes you'll see that colon. And the idea is to just break it. And by the way, that's known as a nibble. So a byte broken into 2 pieces, 2 4-bit items. Each 4-bit item is known as a nibble. So yes, you have a bit, then you have a nibble, and then you have a byte. As us programming, engineering, not even programming, just engineers, all have a sense of humor. And we're always hungry. Note, a normal 8-bit number, also known as a byte, the lowest number it has is 0, and the highest number it has is 255. Now, this is where I go a little bit beyond what the chapter talks about. And that is, yes, 0 to 255, because remember, there's 256 combinations in a 8-bit number that's all ones, but 0 counts for a position. So that's why you have 0 to 255 and not 1 to 256. Just like we have the first 10 numbers of our counting system is 0 to 9, not 1 to 10. Well, and same thing with decimal, it's 0 to 255, not 1 to 256, 0 to 255. However, most times in programming, we use what's known as signed numbers, as in we need to know we have to go below 0. We have to go to the negative side of things. And to do that, computers reserve what's known as the most significant, I just lost it, whether it's most significant. Anyways, it uses the leftmost bit to be a flag, whether it's positive or negative. If it's 0, it's a negative number. If it's a 1, it's a positive number. And when you do that, and you have the same, you have a different sort of number system. It's still 256 possibilities, but now you go from negative 128 to positive 127. So in theory, you're kind of splitting the number in half by taking that most significant bit and making it a flag, whether it's signed or unsigned, or signed as a positive or signed as a negative. But that's what happens when you deal with numbers oftentimes. Now, in a lot of programming languages, you can use and tell the system to use a number that's unsigned. So you can get that full potential. If you always know it's going to be a positive number, you can tell it to go unsigned, and then you know it's 0 to 55. But usually most programming languages out of the box are automatically signed. And so in theory, it cuts your positive numbers down by half, because now the other half is on the 0 side. Understand? So with that being said, let's look at some fun things here. So we don't really deal with bytes anymore. We usually typically deal in what's in a 4-byte system. So we already talked about a 1-byte system. Unsigned goes from 0 to 55, and signed it goes from 120 and negative 128 to 127. 2-byte, here's the number. 3-byte, by the way, 2-byte, this is often known in some languages as a short. But oftentimes we use a 4-byte system. An integer is a 4-byte system, a number. And your range for 4-byte, again, unsigned, is 4 billion and some change, or half that from the positive side to the negative side. Well, why did that matter? Why does that even matter? Well, let's. I love listening to people talk about people that weren't around. Like when I was a kid, 8-bit was a real thing. 8-bit was the only thing, and that's because our computers only worked in 8-bit numbers. So a byte was the biggest integer it could have, and because of that, one of the biggest complexities that came with an 8-bit system is you could only have 255 colors. Well, technically 256 colors. So an 8-bit system, that's why the colors are pretty, they are what they are, like reds and yellows. There's not a whole lot of shading. You got a blue mountain here with no shading on it, right? Because 8-bit only provides for 256 colors. And oftentimes, the colors, even if you looked at it, like sometimes when we go and we use a color picker, it's got that really pretty circle with all the shades, and you can see all the different, it goes from red to blue, and it has the nice shading in between. We don't have that in 8-bit. You had really just these very stark colors. Even up here in this yellow, you can see that there's not a whole lot of shading because they just didn't have, it only had 256 colors to deal with. So then came along 16-bit. By the way, just another little thing too is remember each pixel on your screen has an address. And so again, when it came down to addressing pixels on your computer, the 8-bit system was also very lacking. That's why it's very blocky. It's not very smooth because the blocks had to be a certain size because the screen could only have so many pixels on it. So then we start talking about taking it from an 8-bit system, which is here on the left, to a 16-bit system. So basically, 8-bit squared. It should be 8-bit, 8 times 2, so 32,000 colors. So now we can start to see more shading. We see a little less pixelation versus over here, like this red cloud, there's only so much of this red cloud versus over here because and you can also see in this, there's what's known as banding. So all these colors, when sampled from here, became one color versus thousands of colors. And then finally, this is 16-bit versus 32-bit. And you can tell that on the right side is your 16 versus the left side is 32. And the reason why you can tell is, again, if you start to look at, the screen, you'll see bands of color versus over here, shades of color, like much less banding, right? If you look at the blues in the top here, there's a lot more visible bands of color versus this much better gradient of colors. So I wanted just to give you that as an example, just to see a little bit of weird things differ between 8-bit versus 16-bit versus 32-bit. Again, it's not in the chapter, but I like to talk about those things because it's one of those things that as you really dive into computers, those things will start to matter to you. And you'll start to go, holy cannolis, my int, which is only 32-bit, is not big enough, and I need in some languages known as a big, in some languages known as a long, and if they want, instead of a 32-bit, they want a 64-bit integer. So there you go. So that is the numbering system. Any questions on that? I'm gonna go back to the class, to the chapter here, make sure we covered everything that was in that module. Like I said, that module is not a tough module. I would definitely, before going in, take the quiz, just take some random numbers and write them out in different bases. Get good at doing it. It's a much better hands-on kind of thing. In fact, there is, I believe, a try before taking quiz. And there's definitely a couple of videos on this. Make sure you take at least one video. I think there's two, but at least watch the videos, read the materials, make sure you fully understand how to convert. And then finally, make sure when you take the quiz, like I said, you have to show your work and how you got where you got to. Any questions about that? Okay. Now we can go on to module 9. Don't let module 9 freak you out. It's pretty similar to module 7. In module 7, we talked about list. And in lists, you can have this idea of holding multiple items together in one variable, right? So, and by the way, a list is very similar to an array in many programming languages. I will tell you just a tidbit. In a lot of programming languages, array must contain the same type of object for every element. Here in Python, our list can have different types of objects in that list. So it could be a number, then a string, then another number. It doesn't matter. Well, let's talk about module 9 then. So now we're going to talk about dictionaries and sets. So what is a dictionary? Very similar to a list, except that each item carries two pieces of the payload, which is, and it's got this key and this value. So everything is a key value pair. It's often referred to as mapping of a key to value. The key must be an immutable object, as in, remember what we said about immutable means it can't be changed. The value can be changed, but the key itself cannot be changed. And it should be thought of that way when you're developing these things, that your key is more kind of like a custom index for your list, but because we're using a key value pair, it's known as a dictionary. When we want to retrieve a value from a dictionary, we would use the variable name that we have for our dictionary. And back when we were doing lists, we would then use an index position, or the actual, like if we used we have let's say in a list of strings, we could actually look for where a certain thing is in that list based on the actual item itself, or by the index. Well, this works very similar, except instead of index or the item itself, you're going to give it the key. So what is some standard key value type of items in the world? Like, what do we have that are key value pairs. I'll give you one that I'm dealing with right now, and that is a lot of people that work at, especially larger companies, usually have an employee number. So their employee number is the key, and them as the employee is the value. So all their information, their name, all this stuff, it might be an employee object, and it's got all their valuable information, but they're known by this key, which is their employee number. Any other ideas on key value pairs? For all intents purposes, for those, Social Security numbers is a key value pair. The Social Security number is the key, and then the person themselves again is the object or the value. Believe it or not, to some degree, the internet is a key value pair. When we look up www.microsoft.com, that actually does a backwards translation, and that takes the value and looks for the key, because the key is the IP address. All right. Now we can test whether a key is in a dictionary using the in and not in operators. This is very similar to what we did with the list. You can check to see if something is in or not in. And this helps prevent key errors. We want to avoid key error exceptions, especially since we decided to skip that chapter and aren't really aware of how to catch and handle exceptions. So use your in and not in operators to check if something is in a dictionary. You can add elements to an existing dictionary, and that is to take the dictionary variable name and in brackets put the new key value and equals the value, which is going to be the actual value that relates to that key. If a key exists in the dictionary, the value associated with it will be changed. And that's an important thing to know. The way you update something in a dictionary that already exists is to do the same thing as if you were adding it, but the key that you're going to supply is already going to be in the dictionary. Now, the upside to that is it makes updating something in your list pretty darn simple. The downside is it's also pretty darn simple to accidentally overwrite information. So maybe you meant to add something to your dictionary, but you didn't realize that key was already in your dictionary, and now you've written new information over an existing key, or over the value of an existing key, I should say. Now, if we want to delete an element from an existing dictionary, we use the DEL and then the variable name along with the key that we want to delete. Again, if you have not checked to make sure that that value is in your dictionary, and then you do the delete and it doesn't exist, you'll get the key error exception. And then we can use some of the functions that we've seen elsewhere, like the len function, which stands for length. We can use that to obtain the number of elements in a dictionary. As we've already said, that keys must be immutable objects, but associated values can be any type of object. So in your dictionary, one item could be a string, the next one could be a number, so forth and so on. One value could be a key that the value is actually a list, or it could be another dictionary. The value stored in a single dictionary can be different types. Let's talk about that. So creating an empty dictionary and using the for loop to iterate over a dictionary. So if we want to create just a dictionary, and sometimes we do want to create, we know we need a dictionary, but we don't at the time know what we're going to put in that dictionary. So we can just use curly brackets with nothing in it to signify that a dictionary is created. We can also use the built-in function, DICT, with the bracket, excuse me, the parentheses. And then later you can add elements to that dictionary. We can use a loop, a for loop, to iterate over a dictionary. So a dictionary will return back a iteration. So that's how we know that for key in dictionary. Now remember, now that we're using dictionary, key is going to have both the value and the key. Actually, sorry, let me rephrase that. That's not the case. In Python, when you use a for loop, it will not return the value. It only returns the key. So it will go and tell you what the first key is, then the second key, then the third key. And then you use the key to then get to the value. And that's all you need to get to the value, is to know what the key is. You may not be able to guess what the key is, because the key, like if we were doing student numbers to a student, we may not have 1, 2, 3, 4. It might be 1006 and 1009 and all over the place. So we use a for loop, and the for loop will tell us what the next key is, and then we can use that key to look up the value. Just as we've seen in other places, the dictionary has some similar methods. We can clear a dictionary. We can get items from a dictionary. And we can also, like this dictionary.get, we can use as to get the key. Now, one of the nice things about the get is if it's not found, whatever we put in this default parameter is what will be returned if the key cannot be found. What's nice about that is you can avoid ever raising a key error exception, because if it doesn't find that key, it's going to return the default item that you put in instead. The items method, which returns all the dictionary keys and associated values. So if you went into your instant version of IDLE and you on one line created a dictionary with key value pairs, and then on the next line you said that dictionary dot items, it would list you all the key and value pairs all out at once. By the way, when you do this, if you're using it programmatically, what the items function returns is a tuple. Remember what a tuple is? It's an immutable list. It means it's a list that you cannot change. And then we can use a for loop to iterate over tuples in the sequence. So some of the dictionary methods we have is another group of items we can use against the dictionary is the keys method. Similar to the items method, it's going to return a immutable or a tuple of keys. Pop method. This returns the value associated with the specified key and removes that key value pair from the dictionary, known as popping it off the dictionary. Or a lot of times you'll hear it popping it off the stack, because believe it or not, the two types of memory you have in a computer is the stack and the heap, and the stack resembles a dictionary. It's an address and then value to that address. And as you push things down, it's known as pushing. Well, the opposite is popping. So what it does is it gives you back what that value is and then pops it off that dictionary for you. So it's gone after it's been used. Pop item returns a tuple, the key value pair that was last added to the dictionary. The method also removes the key value pair from the dictionary. So back to that kind of the stack like we were talking about, always remember in a dictionary when you're using like pop item, it kind of goes to the idea that last in is first out, right? So whatever came in last is going to be returned to you and then popped off the dictionary. The value method returns all the dictionary values as a sequence. What is a sequence? Fancy term for a list. And actually, I believe the values method returns a tuple, which is also a sequence, but it's immutable. All right, it is 6:50. I know it's about 10 minutes before we normally take a break, but we're at a good stopping spot after this. Now that we've covered 4 or 5 of the dictionary methods, we're going to come back in 10 minutes and we'll go ahead and talk about some dictionary methods. This is just really a summary of what we just talked about. So we'll start there just to summarize what we just talked about. And then we'll go on to the last bit of this chapter. And then we should be able to take a look at some help with the homework. So I will see everyone back at 7 o'clock and we'll go from there. Okay. So we left off on, like I said, we're going to summarize real quick some of the dictionary methods that we can use. We talked about clear, which removes all the items from the dictionary. The get, which we give it a key and it gives us back the value. If we have specified a default value and the item is not found, it will give us that default value. Items returns all the keys in a dictionary and the associated values, a sequence of tuples, and remember that you can get both the tuple for the keys and a tuple for the values back at the same time. And then pop returns the value associated with the specified key and removes that value key pair. So the pop, it's going to give you back whatever you specify and then pops it off the dictionary. Where pop item just returns the last item added to the dictionary, and the method also then removes that key pair from the dictionary. And then values returns all the values in the dictionary as a sequence of tuples. So dictionary comprehensions. Do you guys kind of remember we went over comprehensions before? So now we're going to do it a little bit with the dictionary. So we can create a dictionary in which the keys are the integers 1 through 4, and the values are the squares of the keys. Remember, when we talk about comprehensions, we're essentially trying to create a way to kind of minimize what we have to type, maybe do something a little bit smarter. And we're going to use the 4 item in a given dictionary. And then out here on the left is where we can then specify the target item and then even do things to that target item. So here in this case, we've got this number is equals 1, 2, 3, 4. We've created a blank dictionary. And then we could do a loop where we say, for all the items in numbers, take and add to the squares the item, which is the 1, 2, 3, 4, and take item and square it. So this is using a for loop. We can do that in shorthand using a comprehension by saying, hey, you know what, take for each item in that numbers, which then stores it into item, we can say take item and square it. And then that's going to return both the item and it's going to, oh, and by the way, this colon, right? What's on the left is going to always be the key, and what's on the right is going to always be the value. So what we're seeing here is the first item on the left here is the original numbers, 1, 2, 3, 4, where the item we got coming back on the right side is the actual value, or in this case, it's the number itself, but we're going to store it as the value, and we're going to square that. So that's why when we type squares, we're going to see this 1:1, 2:4, 3, because this is how you see that when you type a square, type out just the dictionary on the line, it's just going to print out a kind of a shorthand version of what's in that dictionary. So as we did before, we have the 4 items and numbers, and then we have the result expression, which is item colon item, which is key colon value. We'll go back 1 second here. Just remember, we can do things to these, to the results, and whatever we do to them will happen first and then get stored in at whether it be the key or the value. So here we have in our dictionary 1, A:1, B:2, C:3. We have key value. Remember, on the left of the item is the key, and on the right is the value. So for every K, comma, V in dictionaries, now remember, when we use that comma here in the 4, we're asking for 2 values back. And a dictionary has that ability. The first value it's going to give you is the key, and the second value it's going to give you is the value. And then we say in dictionary items, which again, we know is going to create an iterative approach. So it's going to be able to hand us back this key and this value. And then that gets stored over here. And this is what's going to get inserted into our new dictionary if we don't do anything with it. We could have, again, taken this value and times it by 2 or squared it, whatever we want to do. In this case, we were just wanting to copy it basically from dictionary 1 into dictionary 2. And so when we do dictionary 2, we got the same thing as what we had before. That makes sense? It always makes sense when I go through it, right? It's when you start typing it and trying to do it on your own, it's when it gets a little muddy. It's pretty normal. You can use an if clause just like we did before when it comes to comprehensions. So let's take a look at this population, New York. And remember, a key doesn't have to be a number. It can be a value. So New York, the population obviously is this, and then Los Angeles, and so forth and so on. So in largest, we're saying, and again, to read this appropriately, we're going to kind of skip that first part because this is the value that's going to come back, that the area where we can store into our new dictionary. And we're going to say for every key value in our population item, if V, which is the value, is greater than this particular number, it will take that and then go ahead and put it back into that KV over here. And that is what then gets stored into the new dictionary. If it doesn't meet this criteria, if it's less than, what is this, 2 million? Yeah, 2 million. Then it will skip putting it over here in the KV, which will skip adding it to the new dictionary. All right, so let's talk a little bit about sets. So when it comes to a set is an object that stores a collection of data in the same way as mathematical sets. So all items must be unique. The set is unordered, and elements can be different data types. You're going to find that with Python. Python is not a very overly strict language. And so it kind of is like, hey, whatever you want to do, I can do it, right? A lot of other languages can be a lot more strict. Your Javas and your C sharps tend to be a little more strict. And so they have ways to use lists and so forth with different types of objects. But out of the gate, their standard items are usually want to be the same type of object. So how do we create a set? Well, we use the set function. It's used to create a set. So for an empty set, rather than using the brackets like we did before, we're just going to call set with the parentheses. But if we want to do a set that does have items in it, we're going to call the set using the argument, where the argument is an object that contains an interval elements. So it's going to be sort of like a list of items. The argument can be a list, it can be a string, and it can be a tuple. An argument is a string. Each character becomes a set in the element. So imagine that. In a sense, kind of think of it as you've now created kind of like an array of chars, characters. If the argument, so for a set of strings, pass them to the function as a list. If an argument contains duplicates, only one of the duplicates will appear in the set. Here, let me reread that. If the argument contains a duplicate, only one of the duplicate will appear in the set. So essentially, it does a distinct on the items, because it just, when it comes across that duplicate, it won't add it again to the dictionary. Excuse me, to the set. We can do the len function, also known as the length function, to return the number of elements in a set. Sets are mutable, so that means we can change them. We can add and we can update. We can also remove and discard. So remove the specified item. The item that should be removed is passed to both methods as an argument. Remove method raises a key error exception if the item cannot be found, where discard doesn't do anything, the method doesn't raise an exception. Because again, remove means physically go find this item and remove it. Discard says, hey, if it's there, get rid of it. Where the clear method does just like it does on all the other items we talked about, and it clears out all the elements of the set. So here we are using the for loop, the in and not in operators with a set. A for loop can be used to iterate over elements in a set. Again, when you have a set and you use it in for loop, it's going to return back a iteratable item that you can iterate over. And so each item will then be put first into the item, or wherever the variable is. In this case, they're using item as the variable. So that way you have the target and you can use it as you loop through. The in operator can be used to test whether a value exists in a set. Just as we can also use the not in operator to be used to test whether a value does not exist in the set. This is, again, really powerful to test if something already exists in a set, because if it does already exist in a set and you try to add it, it won't. We can take two sets and we can find the union of those two sets. So union is where the item is contained in both sets. We want to do that, we can use the union method. So we have two sets, set one and set two. We're going to take set one, use our dot operator, and say union, and then the parameter we're going to pass is the other set. You can also use this this little pipe. This stands for the same thing in Python. So set one pipe set two tells it to return the only what items exist in both sets. Typically, when we start talking about unions, we often want to talk about intersections. So an intersection of two sets is a set that contains only the elements found in both sets. So hold on. Union is a set that contains, I'm sorry, let me rephrase that. I did get this wrong, so please, hopefully if you're watching this video later, you went further than just my statement, because a union is actually all the items in both sets, right? Again, it's going to, if an item exists in both sets, it's only going to give it once, but it is all elements in both sets union together. So if set one has 1, 2, and 3, and set two has 2, 3, and 4, the union of that is 1, 2, 3, 4. You're not going to get the duplicates. You're just going to get your 1, 2, 3, 4. Where the intersection is what I was talking about, which is it will only give you back the items that exist in both sets. That is, you can do that by doing the dot intersection with set 1 dot intersection set 2. We can also use the ampersand sign, only one ampersand sign, and that is set 1 and set 2. That's what it stands for, is set 1 and set 2, as in both items in those sets, or those items that exist in both sets. And then when you talk about unions and we talk about intersection, oftentimes we're going to talk about difference. So difference is a set that contains the elements that appear in the first set, but does not in the second set. So our earlier example of set 1 was 1, 2, 3, and our second set was 2, 3, 4. The only number that comes out of that is 1, not 1 and 4, because it only looks to the set that is on the left and gives you back only those items that are only in the first set only. That if it's in set 2, it won't exist and it won't return it. And if it's in set 2 by itself, it still won't return that. Only those items that are only in set 1. So we can do that with the dot difference method, or we can also subtract set 2 from set 1. A symmetric difference is like difference, but it now is going to give you any item that is in set 1, not in set 2, and any item that's in set 2, not in set 1. So in our example, 1, 2, 3 being set 1, and 2, 3, 4 being set 2, this would return both 1 and 4, because 1 is not in set 2, and 4 is not in set 1. Good old caret sign, by the way. So in Python, we can do this by dot symmetric underscore difference, or the caret operator. Oftentimes, by the way, the caret operator is on your number 6 key. Just when you thought we couldn't have any more of these. Now we have the finding subsets and supersets. Set A is a subset of set B if all the elements in set A are included in set B. So we can determine whether A is a subset of B. So A would be a subset of B if, let's say, if set A was 1, 2, and 3, and then set B is 1, 2, 3, and 4. Well, because everything that exists in A also exists in B, that makes set A subset of B. So we can determine whether set A is a subset of B is to use the is subset method. And what we're going to do in this case is, because we're looking to see if A is a subset, that's what's going to be on our left. We can use the method is subset, or we can use the less than equal sign to check to see if set A is a subset of set B. I feel like I'm in a Dr. Seuss book. Now, kind of the opposite. A set A is a superset of set B if it contains all the elements of set B. So let's go back. I'm sorry. If set A is a superset of set B if it contains all the elements of set B. Well, set A is a subset of set B if all the elements in set A are included in set B. Whereas set A is a superset of set B if it contains all the elements of set B. So if set A is now 1, 2, 3, 4, and set B is 1, 2, 3, that makes set A a superset of B, because everything that's in B is included in A, but A can have more than what B is. Subset means that A has to have everything that's in B, but B can have more than A. Where superset means everything that's in A is also contained in B, but A is the one that can have more. If B has more, then it's a subset. If A is the one that has more, then it's a superset. Let that settle in for a moment. I definitely recommend playing with this so you get good at understanding these two. So again, to determine whether it's a superset, we can use the is superset method. Or in this case, we can use the greater than equal sign to compare and check if one is the one on the left is a superset of what's on the right. And just when you thought we were done, we're going to also do comprehensions on sets as well. But they do exist pretty much the same. And that is, it's a concise expression that creates a new set. And remember, comprehensions, that's the goal of a comprehension, is to make a new whatever you're dealing with, right? So in this case, we're dealing with sets. So it's going to create a new set. And the set comprehensions are written just like comprehensions, except that a set comprehension is enclosed in curly braces instead of brackets. So if we go back up and look at our comprehension from before, you'll see that we have curly brackets here. Oh, sorry. So as you can see, our original, when we talked about dictionaries, we use the dictionary setup. So we have, key value pair. When we talk about sets, we're going to use the brackets to help set up a set, right? And then the comprehension comes next, which is, again, we can break it down. So here is the for piece, and then whatever is pulled out of this is then stored into this variable, which then gets written into the new set. So this will make an identical copy, it's known as a deep copy, of this set. So we're going to say 4 items in set 1, essentially store it in set 2. Just like before, we can also do things to the item right before it gets stored into our new set. So we can say, give me everything that's in set 1, and then take that and square it. And that's what's going to get stored in our set 2. So our set 2 is now 1, 4, 9, 16, 25. So now we can copy this is an example of copying the numbers in a set that are less than 10. Because again, we can use, just like we've done before, we can use the if statement. So in this case, we've got, hey, give me all the items from our set 1, then run it through this filter. If the item is less than 10, it will then get stored into this temporary variable item that then will get written into our new set. So in this case, we're going to pull 1, 2, and 3 out. Now, before we have taken some items and we have written those items into a file. And we kind of did it in a manual method. We took what was essentially a record of 3 items per record, so 3 fields per record. Remember, we wrote them to a file, and each item was then separated by a line break. And then our records themselves were separated also by a blank line of data. But when we take and we serialize an object, we're taking that object and we're saying, hey, go and convert it into a method that I can then easily put into a stream. Now, a stream can do a lot of things, but oftentimes when we talk about a stream, we're usually talking about reading or writing to a file. When we serialize an object, it's known as pickling. Other languages call it hydrating or dehydrating. In Python, we call it pickling. So when we serialize an object in other languages, it's called dehydrating. When we unserialize it, it's called rehydrating. So to pickle an object, we're going to import the pickle module. That's why it's called pickling in Python. We're going to open a file for binary writing. Now, this is different than what we did before. Before, we were writing things in a text file. We're finally going to start writing things in a binary file. We're going to call the pickle.dump function, and then we're going to close the file. So now, just to recap, make sure everyone's on the same page, an object is what we've been creating all along, right? So a set is an object. A dictionary is an object. All these items are objects. So we can take a dictionary and write it directly to a file. And we can use this pickle.dump to write it in a manner that it does all the work for us. It pickles the item for us, writes it to the file for us. Done deal, easy deal, you're done. And then you close the file. Now, you can pickle multiple objects to one file prior to closing the file. Typically, I don't see that happen that often because now you're taking what should be a pretty simple process to pickle and unpickle an item, and now you're complicating the issue. So most of the time when people are taking something and pickling it right to a file, then they will oftentimes do just one per file. Well, now that we have pickled an item, we need to unpickle it. So, so unpickling is retrieving that pickled object. To unpickle an object, you're going to import that pickle module again. And you're going to open that file that we just wrote, but we're going to open it in a binary. And then we're going to call the pickle.load function. And that format is pickle.load in the file name. And then close the file. Again, you can unpickle multiple objects from the file. You know, I believe in that case, though, they do all have to be the same type of object. There you go. So in this chapter, kind of to wrap up the semester, we have talked about dictionaries, and we've talked about sets. And we've talked about in each one of those how we can do certain things, the list of methods that each item has. We've also talked about how we can use loops on both the dictionary and the sets. And then finally, we use the in and not in operators to talk about how we can, the in and not in operators to check either a set or a dictionary to see if something exists in that item already. And then finally, we talked about how to serialize objects, which is also known as pickling and unpickling. Serializing is known as pickling. Deserializing is known as unpickling. Any questions? All right. I'm definitely, my voice is a little rough tonight, and so I've been drinking a lot of water, but let's go ahead and take another 10-minute break. And then we come back, we will talk about some of the items you're going to need to know for the homework assignments, and then we are pretty much done. So let's take that break, and we probably won't be much longer. So let's go ahead and take a 10-minute break, and then we'll return back after 10 minutes. So so what we're going to do is we're going to go ahead and start up IDLE. We have an assignment. The assignment goes along the lines of, hey, let's write a program that uses a dictionary to record 5 courses in their current grades. Start with an empty dictionary and then use a loop and a keyboard input to specify the course names as keys and numeric grades as values. After all 5 courses have been entered, use another loop and the items method to display the course name, the grades in a table, nicely formatted as you see fit with an F string. The second loop should also determine the course name and grade of the course with the lowest grade. Report the course grade name and grade. When the loop ends and the delete drop that course from the dictionary. If math is one of the courses, add 3 points to the math grade. Otherwise, report that math is not in the dictionary. In one final loop that doesn't use the items method, display the updated courses and grades again in a table. The final loop should also determine the total of all grades, so the term average accurate to 1 decimal place can be printed after it ends. Okay, so we're not going to go through all of these items. We're going to give you some of the bigger pieces to this. I'm also going just, so you can appreciate, I'm not going to do some of the standard items you should be doing now, right? I'm not going to create a def main. I'm not going to use the main variable to see if its name is main to run main. I'm not going to do that in my example. You should definitely do that in your homework. But at this point, because we're just trying to focus on, some of the concepts we just went over, I don't need to really worry about those items. I know that you have them all. And when you do your homework, that's part of what the homework would look like, right? But we are going to start out with some pseudocode. So let's take this and put this down here. And we'll go up here. So it says, write a program that uses a dictionary to record 5 courses in their current grades. Start with an empty dictionary. So right there, we already know we need to create an empty dictionary. Then we're going to loop 5 times. It's very specific in our requirements here that they want us to do 5 times. And when we do that loop, we're going to ask user for input on course name. And then we're going to ask user for input on course average. Should be number. Then we're going to, once again, loop using items method. And output to console using F string. Now, when we're going through this second time, we can also observe if this score is lowest. All right, so those are the main things I'm going to go over. Some things that I'm not going to go over is once you find what that lowest score is, how to delete. I want you to make sure that you spend some time trying to work on some of this on your own as well. But this should get you a good start. So how do we create an empty dictionary? Well, we say the name equals with an empty bracket. We could also do it as that gives us an empty dictionary. I like the simple way of just empty brackets. Now, as we're getting better and better in our programming, right away as a developer, when I see someone go after all 5 courses, or start an empty dictionary and loop through this 5 courses, the fact that they keep hard coding 5 into this, I'm going to go, yeah, but I know down the future they're going to change it, right? So I'm going to stick to their 5 as a requirement, but I'm going to make things. I'm starting now as a developer to kind of forward think things. So I want to go ahead and say, let's go ahead and create a constant variable with that 5 in there. So that way we know that if for whatever reason, especially during testing, you want to reduce this down to, let's say, 2 classes, so you're not having to typo over and over and over again while you're testing, you could put this to 2, and then just make sure you put it back to 5 before you submit, because then you've made it to where you're following the requirements, but you as a developer wrote some really good development code that can easily be modified to quickly take in and start going to 5 of these items rather than, or 6 or 7, whatever they want to change, right? Remember that? Range, number, and we're using our constant. So let's go ahead and ask for that input. So the first thing is the course name. Sorry, got ahead of myself. Now, again, I am following the requirements very literally. The fact is, I'm at this point really not going to ever use my X variable here. So, I mean, if you wanted to, you could, maybe get creative and have a little bit of fun. I'm not going to penalize you for, having a little fun and testing your skills out, right? So you could say, and then the next thing we need to do is ask for the average, right? So course average. And we're going to nope, I snuck that in before there we go. So one thing I'll tell you is I oftentimes, as I'm developing, will get to a certain kind of I'll develop a chunk of code that works together as a unit, and then I'll test it. So we're gonna go ahead and do that. Oh, and see right away, there's no such thing as 0 of 5 when we're talking about what we know as numbering systems. So let's go ahead and just stop that and fix that. So there you go. So far, so good. It's working. Now this says, after all 5 courses have been entered, use another loop in the items method. So they're being very specific about how to do this loop, right? So we know to do that, we're going to say, and because we can take 2 values from this, we're going to say oh, I'm sorry, I never added this to, so we've asked questions, we've got the information back, but we never added it to our dictionary. So here's our dictionary. And remember, we can now go ahead and use our course name as the key, because a key can be a string as well. And that, the value for it though, is this average. And we're going to now get 4, and we're going to get both values back, the temp key and the temp value. And we're going to use items method. Now, I'm going to purposely kind of use a silly way to do F string to print out this table. There's a better way to do it, I'll tell you that. And so I'd really like for you to think about that on how to use an F string and be more exact on how you do your output. But for now, I'm going to say print F. Just put 2 tabs in. But you should use formatting, hint, hint, instead of 2 tabs. So again, another good stopping place just to see if we're still doing a good job here. Man, this is taking forever because I have to keep typing in all these items. And, so there you go. Now, while we're testing and we're playing with our code, let's go ahead and reduce this down to 2 so we don't have to keep typing in as much. We just want to make sure before we submit this, we put it back to 5, right? But now we don't have to type as much, and we did it real easy. It's nice and located in one spot to do it, so it's great. Now, while we're going through, we can go ahead and observe if this is the score is the lowest. So let's go ahead also and just make a variable that can hold for our lowest score. Just to make sure, again, kind of a little bit old school for me. I like to set some kind of value to a variable right away. I'm going to overwrite it from the very beginning. I'm sorry. We're going to because we want to make sure that this is a really high number. So it won't cause us any problems. Whatever is the very first number will always be the lowest. So now we can go. So what I'm doing in this if statement is I'm saying, hey, you know what? Take whatever value I just got back. Is it lower than what I have recorded as the lowest score so far? It is? Great. Now make that temp value my lowest score. So if the first iteration we know is going to be this this huge number, so it's going to always be lowest score. So we can go ahead and we know the first time we'll come in, it's going to say that the lowest score is bigger than the temp value. So it's going to go ahead and say, take the temp value and put in the lowest score. So let's say that one is 10. Well, the next one's 20. Well, temp value won't be lower than lowest score. So we'll skip this and it will not save the current temp value in the lowest score. Oh, by the way, because I used that constant and I decided to put it in my parentheses as well, the fact that I changed it to 2, it also changed everything in my parentheses now too. All on because I made one change. Well, that's great. But let's just run it again and make sure that we do it backwards maybe. Because remember, we don't want to just happy path test. We want to try to change things up. So now I've reversed it. So now 22 is my lowest, but it was the second number versus the first number. I just wanted to make sure not to do just happy path testing. So far, so good. Now, with this, you're going to need to delete or drop that course, right? So the delete, the drop course, right? We already know what the temp value is, or what the lowest score is, right? We may want to store some indication of what that key was as well. So that way we can take that key and use it to drop the item. Or maybe we want to remove it or just discard it, something along those lines. And then finally, we're going to make another loop that doesn't use the items method. So something that we kind of different than what we've already done. And we're going to use an accumulator. Remember what an accumulator is? That is a variable you set up before the for loop that you will keep adding to. And you're going to do that so you can loop through and determine the total of all the grades. So you can then use that to create an average of all the grades. And again, instead of using the hard-coded 5, use your constant for that. And then you want to output it at the bottom. There you go. That is the homework. I did a lot of it. Some things that you'll need to go through and kind of pick out and maybe change up. Again, if you're in there and you want to be a little bit fancy about it and add some cool stuff to it, you know, there's a whole lot of places you can get really cool with this. If you wanted to make sure that they don't give you a negative number, you know, if you are like any other class, if you're going on a 0 to 100 score base and not a point base, then you'd want to check maybe that they didn't go over 100, right? Or maybe you consider that they can get more than 100. Some classes, you know, someone could get extra credit and get more than 100. So maybe you let it go to 130. Who knows? You know, you could set up a while loop to make sure that your inputs are coming in correctly. And if they don't come in correctly, that you then re-loop and try again. You may want to take your inputs and function them and put them out into its own function. And you pass in the question and get back the answer, right? So you can really utilize all the skills you attained through this semester to do this. Or you can really keep it very simple as well. You know, I'm not going to penalize you for either way, but if you want to have some fun, you know, get creative. Definitely, I probably would, for someone that has done a really good job and really sectioned things out and done a good job to show some of the things that they've learned through the semester, I wouldn't have a problem giving some extra points to the assignment, especially if you are a little low or you think you might be on the borderline of maybe a BA kind of thing, and you want to get a couple points, you're more than welcome to do that. And like I said, going through this as I grade it, if someone has done a really good job and gone above and beyond, I'll give a couple extra points for the assignment. Okay. Any questions? So that is tonight's class. I know that it didn't go as long as our full class. Sometimes it does, sometimes it doesn't. The numbers section can definitely sometimes be something that holds the class up. And so we didn't have a lot of problems, not a lot of questions. So we got through tonight pretty quickly. I will be here for a little bit longer in case you have questions. So feel free if you want to do some homework to do so. If I don't get any additional questions, I probably will head out in about 15 minutes. All right. Thanks, everyone. And again, great class and a great